1/2 x, 1/2 y. So first of all, what we need to understand is that this equation is a linear equation. How do I know it's a linear equation? Because, for example, it does not have x squared or y cubed. No. It does not have a product xy equals 4. No. This is not linear if it's a product of the variables. Variables have to have power 1. They do have power 1, but so do here. Yes, they do, but it's a product of two variables. So this is not, if I see elements in an equation like x squared, y cubed, x to the third, or whatever, anything other than power 1, I will say not linear. If I see a product, that's not linear, product of variables. If I see x squared equals 1 over y, no. No variables in the denominator. So 1 over x equals y is not linear. No. Because it has variables in the denominator. So variables in the denominator are not accepted. Other powers than power 1, not accepted. I mean, they exist, but they're not linear equations. Okay? Products of variables, no, not possible in a linear equation. So what is possible then, again, in a linear equation? Only maximum two variables, x and y, and the power 1, and no products of variables. Now, what is so important about linear equations? Well, the graph is a line. That's why it's so important to identify it. Identify it, it's a line. Okay, now, we only need 2 points to define a line. 2 points are required to define a line. Can I find 100? Yes. But you only need 2. Why? Through 1 point, I can draw infinitely many lines. But through 2 points, there is only 1 line that passes. The third one is redundant, the fourth one is redundant, the fifth one is redundant, doesn't matter anymore. I only need 2 points to define a line. And I like to start with this example. Let's say y equals 1/2 x. Well, I want to graph this function or this equation. I know it's a line. Please don't graph it like this. Don't graph it like this. It's a line, a straight line, in other words. Good. How do I make up points? Okay, here's one option to write a table and choose some values of x. Of course, I want to choose 0. Of course, I want to choose 2, because 1/2 times 2 gives me a nice number, and stop. There is no need to waste my time. That's what I need. I need 2 ordered pairs. So then I draw the coordinate system. I plot the 2 ordered pairs. I put the arrows on the positive side of x and the positive side of y. I see that the line passes through the origin, and 2, 1. This is the point 0, 0. This is the point 2, 1. I connect and extend, put the arrows, and always write the name of the graph anywhere you want. Above, below, left, right, but it has to be on the graph. That's all I need to do. Can you find other ordered pairs? Of course, you can find infinite. But you cannot pick. You cannot pick. You pick x and you determine y. You cannot pick 2. I'm going to say, oh, I'm going to pick 2, 3. No, you cannot. You can pick x, but you have to determine the corresponding value of y. So when I plug in 2, I get 1. Okay? Or you can plug in, you can pick y and determine x, but you cannot pick 1, 7. That's it. No, you can't. Because when x is 1, y is not 7. So this point is not on the line. to determine points that belong to the line or verify the equation of the line, you pick x and you determine the corresponding y. Good. Now, what if I have the following equation? Notice that this line did not have a free term. What do I mean by free term? By free term, I mean this equation was y equals 1/2 x plus 0 if you want. There is no need to write this, right? So this line passes through 0, 0. The line that does not have an element that is like this, no variables in it, will always pass through the origin. In other words, the x and y intercepts are the same point. So a line that does not have a free term, like this one, I specifically chose this. This line passes to the origin, meaning the x and the y intercepts are the same point. Okay, so now let's look at another example. Any questions, please always stop me, please. Okay, so if I have x minus 2y equals 4, I want to graph using x and y intercepts. This is the easiest thing to do. Now, there are situations in which in Pearson you will not be able to. And I'll show you an example in which you will not be able to determine. I mean, you are able to, but you're not able to enter it. So I'll explain in a minute. So let's just worry about this one for now. Good. So remember, to determine the x-intercept, I make y equal to 0. To determine the y-intercept, I make x equal 0. This makes it very, very easy. So here's how I do it. So x minus 2y equals 4. When x is 0. Negative 2y equals 4 means y equals negative 2. And I write the ordered pair right here, right now. Do not wait for later. And I'll explain why. Because students sometimes combine the two, and that's a tragedy. So, cover it up. When x is 0, y is negative 2. I found the point 0, negative 2. When y is 0, cover it up. X is 4. X equals 4, and write the ordered pair right here, right now. You cannot create an ordered pair 4, negative 2. That will be a tragedy. Do not combine the two. They are different things. Okay, now I'm ready to graph. I found the x and y intercepts. I have 0, negative 2, and I have 4, 0. Connect and extend the line, and you're done. Of course, you have to write the name somewhere. Above, below, left, right, it doesn't matter. It has to be there. X minus 2y equals 4. That's it. That's all you have to do. Do not waste your time solving for y. Do not no, none of the above. However, you may be asked to use x and y intercepts, or you may want to use x and y intercepts to graph on something like this. Let's say 3x plus 2y equals 1. There is a problem here. With Pearson, nothing wrong with what I'm showing you. So when x equals 0, y is 1/2. The point is 0, 1/2. When y equals 0, x is 1/3. So the point is 1/3, 0. You will not be able to enter these in the graphing in Pearson. They are perfect, but you will not be able to. So they wouldn't.
Technically correct.
Say it again.
That is technically correct.
It's not correct. It's 100% perfect.
Okay.
But you cannot, the system will not let you plot 1/3 because
Right.
they don't have that. That it's not as smart as you think it is, or I think it is. So it will not let you. Okay, fine. But how are you going to graph? Well, we have to find other points to use. So, for example, when x is 2, let's see, 6, no, when x is 1, let's see what happens when x is 1. When x is 1, I have 2y equals -2, so y equals -1. So now you can plot 1 comma -1 because the system, this is just for the system, it's not for us. But for the system, you will not be able to, Pearson will not let you enter that. So you have to find another ordered pair that is that uses integers.
Do you know if the test will be like Pearson's?
I think that they will avoid a possibility like this, but they may ask you to graph using the x and using not the x and y intercepts in this case, but using the slope. So you will be able to determine other points. That's not a big deal. I just wanted to, give you the heads up on that. Okay. Now, we already started from the very beginning by graphing vertical and horizontal lines. This is what we did when we started Mod 4, because this is very important. Vertical lines look like x equals 1, x equals 0, x equals -10, and so on and so forth. They only have x. They show position. Horizontal lines have only y. Y equals 0, y equals -3, y equals 4, because they are representing altitude. So vertical lines only have x in their equation. Horizontal lines only have y in their equation. Very easy to graph. Please choose one from each so I can illustrate. Although we did that last time, it's okay. Let's do it again. Choose one of each or make up one. Don't say x equals 100. Just give me any x equals. So
Equals 3.
X equals 3. 1, 2. This is x equals 3. Give me any y.
Y equals 3.
Y equals 3. 1, 2, 3. Horizontal line, y equals 3. So we know how to graph horizontal lines and vertical lines. We know how to find x and y intercepts. We know how to graph lines now using x and y intercepts, and we know how to graph horizontal and vertical. We are ready to review the learn part. You tell me if there is a need for anything. And let's practice. I'm sharing my screen. Okay. Good. Okay. Determine whether or not the equation is a linear equation in 2 variables. Is it a yes? Is it a no?
Yes.
Yes, because x and y have power 1. They are not found in the denominator. I do not see a product x times y. The powers are 1. It's clearly a linear equation. And it can be written in this format. So let's talk a little bit about this. Is a useless format, but it's mentioned, so let's mention it. So any linear equation can be written in that format. This is called the standard form. It's not useful because we cannot read anything from it. So the example that I had, 3x plus 2y equals 1. What is the standard form? a number times x plus a number times y equals a number. Yeah, a is 3, b is positive 2, c is positive 1. That's a standard form. In this example that they have here, which is 7x minus y equals 16, this equation is in standard form, where a is 1. Of course, the numbers are taken with a sign in front, so this is negative 1, and c is 16. So they will ask you to enter for a 7, for b negative 1, and for c 16. There are other forms, since we mentioned this. So there are 2 other forms that are extremely useful, and we're going to talk about them. Okay, so this is standard form. This is the slope intercept form. This is a little bit confusing. When we say slope intercept form, we mean y-intercept, not x-intercept. So slope intercept form. And the other one is point slope form. I'm going to put them here, but they are not, we are not getting there yet. Not in the next few minutes, okay? So I'm going to write them down for you. Y equals mx plus b, where m is the slope of the line. What is m? It's the steepness of the line. So I can definitely walk on this line because the slope is 0. Here I can, it's not too difficult. Here I can, it's getting harder, steeper, 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 and definitely I guarantee you I cannot walk on this. Okay, so from slope 0, very easy to walk on, maybe slope 2, maybe slope 5, maybe slope 15, but then it gets harder and harder and harder. This is the meaning of the slope. This number will give us the steepness. If it's horizontal, it will be 0. If it's like this, it may be 2. If it's like this, it may be 3. If it's like this, it may be 15, whatever. So that's the slope. What is this? It's the y-intercept. B is basically 0, comma b, the y-intercept. We're going to talk about this a lot. Now, the other one, the point slope form. Y minus y1 equals the slope, the same thing, and in parentheses x minus x1. M is still the slope, but what is this x1? So this is the point. This is the given point, x1 comma y1. Given point, x1 comma y1. And I can determine the equation. One final formula here, and we're going to get to them, is the slope formula. Assuming I have 2 points, given 2 points, and that is rise, which means difference in y values, rise over run, difference in position. So y2 minus y1 over x2 minus x1. Do not reverse these. It's always the difference in altitude over the difference in position. Okay, back to the problems. We're going to work on these a lot. Determine whether or not the equation is a linear equation. Yes, no, and why yes, and why not. Is this linear?
No.
No. Because?
There's 3 powers.
Because
there's 3 elements.